Okay, when you run a Ruby program, a little universe or space, or this gets philosophical, it's nice. A little universe gets created. And it gets populated with objects, with things. And those things are defined by your program. They interact with each other, and they do useful stuff, hopefully. And they do that using methods that you define and that you call. Also, each object is an instance of a general idea or a type. And those ideas or types are called classes. You can see objects have classes when you look in IRB. We just talked about this morning. If you call .class, it tells you what type an object is. In Ruby, everything is an object. That's not true in other languages. In some languages, we have these things called primitive data types. So in a lot of languages, things like string, character, integer, decimal or float, byte, boolean, those are all primitive data types is what they're called. So they're built into the language. They're not objects. There aren't classes defined for them. But in Ruby, everything is an object. A string's an object, an integer's an object, a boolean's an object. Everything's an object in Ruby, okay? And we can see which class an object belongs to in Ruby if we use the .class method. So the .class method is a method that's defined on the basic object type in Ruby. So it's available to in every other object subclasses from that basic object type. So we have that .class method available on any object in Ruby, and we can use it to see what class this object is an instance of. So classes are like templates, like I mentioned yesterday. They're like templates for objects or blueprints. They describe what an object's attributes are or can be, and what the methods are that we can use to operate on those properties of that object. And an object is a manifestation or instantiation of one of those templates or classes. So if you think about the blueprint for a house, you can't live in the blueprint. You can't make dinner in the blueprint. You can't lie in bed in the blueprint. You can't flip light switches in the blueprint. You have to make a house. You have to instantiate the blueprint and make an instance of a house. And then once you have a house, that house will have particular attributes that belong to that house. So it has blue paint, and it has this size living room, and it has a king bed in one of the bedrooms, and it has light switches that you can use to turn the lights on and off. So, but those things only exist once you actually build a house from the blueprint. So that's the distinction between objects and classes in Ruby. So with the string class, you can't do anything with the string class. It's not useful except to serve as a template for string objects, for objects that are instantiated by calling new on the string class. Now when we say variable equals empty string, we're actually calling string.new. That actually results in calling string.new. We actually create an instance of the string class. So we have to create instances of classes, which we call objects, in order to do anything useful in programming with object-oriented programming. So in Ruby, the syntax for defining or declaring or creating a class is to use the class keyword. So for methods, we use the def keyword. For classes, we use the class keyword. And just like everything else in Ruby, to end the definition for a class, we use the end keyword. We give the class a name, and the convention in Ruby is that we use Pascal case for class names. That's first letter's capital, and the first letter of each word is capitalized. So if we had a name like scientific calculator, then scientific would be capitalized and calculator would be capitalized. Okay, so that's called Pascal case. So it's written camel case on here. I need to change that. It's actually Pascal case. Camel case starts with a lowercase letter. I'll fix that later. Once we've defined a class, and we'll talk more about that in just a moment, how do we actually define a class, this template? Once we have a template defined, though, a class defined, then we can create objects, which are instances of that class, by calling the new method. The new method is a special method that's available on all objects. And when the new method is called, a special initialize method is actually called in our class implementation. Okay? And that returns, that initialize method, which is invoked by new, will return an instance of this class. So we can define an empty class, and we can instantiate it. It's not going to be able to do much, but we can see any class, like I said, extends the base object class in Ruby. And that base object class has some methods. Let's have a look at what some of those are. So if we just say an IRB, let me just clear to go to the top of the screen. An IRB, if we say object.methods, I mean, that's a pretty good list. You know, that's like, there's a lot of methods there that are just available on objects. So we have new. There's new right up there at the top. We have things like include, kind of, is a, instance of, instance variables. Yeah, so we've got quite a few methods that are just given to us. And all we have to do to have those instance variables is to define a class. And it can be empty. Okay, so if in if we just define a class called calculator, and that's it, and then I create an instance of it, I've just created an object called calculator, which is an instance of my class, or an object called myCalc, that's an instance of my class calculator. And then I can say myCalc dot class, and I can puts that so I can see it. And then I can check things like myCalc dot instance of calculator. And what do we expect that to say? So, yes, true. So without me running this, what do we expect this to print out if I run it? Anybody? What about the first line? The first puts? Calculator, yeah?
Oh, yeah.
It annoys me that this doesn't go to the directory that I'm in. So, if I run my little program here, it tells me that myCalc's class is calculator, and it is an instance of calculator, which is the same information. Both of those things really tell me about the same information. But that's all that's required for me to create a class. Okay, it's not a very useful class. I can't do anything with this calculator. I can look at, though, what do I get with if I just say puts, which is going to call the toS method on. So this is what toS does by default. toS defined on object by default prints in this notation, this beautiful handy notation, the name of the class and the object ID. Okay, so when we instantiate an object, it gets assigned an object ID, which will be related somehow to the location in memory that we're pointing to that's storing the information for this object. Okay, so by default, 2s gives me that. Let me just show you something cool we can do. We can do this. Now when I call puts on my instance of calculator, it says a calculator. So in Ruby, so this 2s is a method that's defined on object. Okay? Ruby allows us to override any method we want on any class we want. We can do class string and then override any method on the string we want. And that's called monkey patching. And it was added to Ruby so that when we use third-party libraries, so not our code, somebody else's code, whether it's in the standard library or a gem that we brought in, and it's broken, or at least for our purposes it's broken, it doesn't work the way we expect it to, we can override those methods ourselves and fix it, which is a dangerous thing to do. Because then if you update the version of this thing that you pulled in, your monkey patch is broken. Potentially, right? Yeah.
It's actually quite handy when you're wanting to display a hash in a particular pattern.
Absolutely.
You can override the two-string.
Overriding 2s or 2-string is it's a really handy thing. Because the thing to know is that when you call puts calls 2s on whatever you pass to it. Okay? So if I say puts myCalc, it calls myCalc.2s and displays the result. That's what puts does. Alright? And by default, 2s gives us this information about an object. 2s is overridden on common object types like integer and float and string and objects that are defined in the standard library. 2s is overridden in those definitions of those classes to print something nice, something the user would expect to see. Now, once we implement this calculator class some more, we give it some attributes and some methods, there might be something more meaningful than just saying a calculator that we can print out when somebody calls 2s. But I just wanted to show you that we can override this behavior of what we see printed with puts by overriding 2s. And notice in my 2s, I don't have a puts. I have a return. I return the string that I want to display when puts is called. I don't do a puts in that method. Okay? Okay, let's go back to the slides. Any questions so far? Okay, so to make this a useful class, we have to define some attributes and behaviors for our calculator class. So maybe we only need behaviors. I don't know if we need attributes. Attributes of a calculator. Maybe whether or not it's scientific. Maybe a list of the things that it can do. Not all calculators were created equal. Some calculators we can get the absolute value of a number and some we can't. Some calculators we can do graphs with. Some we can't. So, for now, we'll add a basic method to our calculator, a basic action to perform. We definitely expect that a calculator can add. So any calculator we expect to be able to add. So an add method for a calculator at the very least needs to take two numbers. And that would be enough, because even if we wanted to add more than two numbers, we could just call add multiple times, couldn't we? And add with two numbers, just like we did in that exercise yesterday when we did the largest number. And I said write a method that takes two inputs and gives me the largest number. Now write a program that takes three inputs and uses that method that takes two inputs and get the largest number. Okay? So we can define an add with two numbers in our calculator method. Now, the slide points out that the first thing to note is we define this method inside of the calculator class, so between the class declaration and the end. The second thing it points out is that the syntax is the same otherwise, but we call it an instance method. And we call it an instance method because it's defined inside of the class. This becomes a method, in addition to all the other methods that we inherit from our superclasses, like objects. This adds a method to the things that we can call on calculator. Now we'll be able to call a method called add. So any instance of calculator will have this add method available. Once we've defined an instance method, we can call it. Just the same way we call methods on any other object in Ruby. So let's have a look at that. If we wanted to define an add method, it makes sense, yes, to everybody that we would pass two parameters to that add method? Yeah? And what should we return? Anybody?
Num1 plus num2.
Yeah. And then once we've added that instance method, we can call it. Nice. We have a calculator that can add now. And if I do, if I said, maybe I should do, there it is though. Do you see it? So there's our 2s, and there's add. So now add's a method that we have available on this calculator class.
Is that a thing that adds the real custom class?
Custom methods, yes. Yeah, so it looks to me like that's the order that it prints things out at. Yeah. As if I've added at the subclass level, at the lowest class level, it shows me the methods that were either overridden or added with that class implementation, and then the ones below it would be from superclasses. Yeah.
So just a quick question. With the mycal equals calculate.new,
Yes.
if we don't do that, can we not access the class?
Yes, that's correct. So that is the way that we instantiate a class. Yes. And we can do that with any class. So like I mentioned that usually the way we instantiate a string is we just say variable name equals quoted value. But that actually is calling string.new in the back. It's just not visible. So with some special built-in classes, we've been given another way, another method basically, with different notation. So we don't have to call it .new, but you can call string.new. Okay, so we can extend the functionality of our calculator class by adding more methods, right? We can make it more useful. So we can add subtract, multiply, and divide, and then we can test those that we've done them correctly by calling each method on our calculator instance. Okay, so you guys, I'll give you like 5 minutes to give that a go. So add. Has everybody followed along with me so far? If not, I can give you this code. So if you can add a subtract, a multiply, and a divide, I'll give you like 5 or 10 minutes, and then we'll look at it together. Okay, how'd you go with that? All right? So the first thing is that these methods need to go where?
Inside the class.
Inside the class, really important. Not outside the class, inside the class, right? And otherwise, they look just like any other method. You know, they really do. So what would I put in my subtract method?
Num1 minus num2.
Yeah. All right, thanks. And what about in the multiply method?
Num1 asterisk.
Yeah, and the divide method.
It's num1 equals.
And then I've just added some calls to them here with the same numbers, 5 and 1. So add, subtract, multiply, divide. I might put a little bit of context around these put statements. Adding 1 and 5, 5 and 1, we'll say 5 and 1. And then I'll use some string interpolation. Am I confusing anybody? Is this all clear what I'm doing here? Subtracting 1 from 5, use some string interpolation. Multiplying 5 and 1, string interpolation. And finally, dividing 5 by 1 with some string interpolation. That'll make it easier for me to interpret the output I get, yeah? Oh, what happened? I misspelled. Can you see that? So let's just look at the error message and get used to reading them. What does it say? Multiply. Undefined method. But then it's so nice because it says, did you mean multiply? You silly thing. Yes, I did, Ruby. Thanks. Cool. Yeah, I didn't spell that right, but it was just in my print statement, so it didn't care.
Is there an extension that would catch it in straight?
Misspellings? No, you have to write your own spell checker. Because that's just me printing something out to the screen.
Yeah.
Right? And yeah, so there's no built-in spell checker. Yeah. But I'll fix it anyway. Okay, so any questions about that? Oops, I don't know what just happened. All right, cool.
No, it's not working for Jack.
Not working. All right, what error are you seeing, Jack, or what's happening?
Unexpected key identifier, expecting what I have there.
Okay, so what line is it pointing to?
All of my puts line.
Okay. Is it a quoting thing?
Yeah.
Okay, cool. Natalie, come up here. Come up here. Okay, cool. So, we can, when we initialize an object, oftentimes, it makes sense for us to initialize it with some kind of information. Okay, so with a calculator, not so much. Maybe, if we wanted to create a scientific calculator versus, a regular calculator, then maybe we'd want to pass in what kind of calculator we're looking for, but probably we would accomplish that a different way with subclassing. But if we wanted to define something like a person, then there are a lot of use cases for defining a person object, isn't there? So any system or application that we define where we have to represent a person, we would want to have some kind of person class. We might call it person, or we might call it customer, or we might call it client, or we might call it user, but there are a lot of cases where we need to represent a person as an object for some use. So it's a pretty common case. Now, when we have to represent a person in our program, usually we want to, when we instantiate that person, provide some information about them, like a name, for example, right? So we can define parameters to the method that gets called when we call new on a class. And then those parameters can be used to set some initial attributes about this object. So the initialize method is a special method. It's special because it's what's called when we call .new. All right? Initialize is defined an object, and it does some stuff. For example, it allocates a space for this instance and assigns an ID to the object. Okay? It defines that it's an instance of this class. All the stuff that we can see returned from the basic methods that are available on object, that gets set up in the initialize that's defined in the object class. Okay? So when we override a method in our classes that we define, then we can specify how we want that method to be implemented. Okay? So when we want to set up some properties of a class when it's instantiated, and we almost always do. Not always. Like our calculator is a good example where we may not need to initialize any properties. We just want to have actions that we can perform on a calculator, and that's it. It doesn't have to keep up with any state or information about itself. But a person, we would have attributes associated with a person, and we would define those attributes in an initialize method. So notice that initialize is spelled the American way with a Z or a Z, and that's important. It doesn't work if you spell it with an S. Okay? So this is true with most programming languages. The keywords are American spellings. So just remember that, and that it's important. So if we in our initialize specify a name for a person, for example, then we can pass that to our initialize method by passing it to new as an argument when we call new. And the result of doing that will be that that parameter will be passed to our initialize method. Now, we need to talk about instance variables, because what do we do with this? How do we store this information inside of the instance? We have to have a way to do that, and we're going to do that with instance variables. So instance variables are used, I'm going to use the word state here, okay, because state is a common word and it's going to come up when we talk about JavaScript too. So you can think about the variables that describe the properties of a class instance as representing their state, the state of this particular instance. And the instance of a class needs to keep track of its information. It's responsible for doing that. And the way that it does that is with instance variables. So let's look at what instance variables are and the syntax for them in Ruby. So in Ruby, we indicate that a variable is an instance variable using the @ symbol. Okay? The @ symbol means I'm defining an instance variable. And what the result is that variable is available everywhere inside of my class. Inside of my class definition, and any methods defined in my class definition, I have access to those variables. So I can set them in the initialize method, and then once they've been set to something, they've been declared and set to some initial value, I can access them from any method and get access to that variable and change it. Okay? So these are the variables that are associated with my class instance. So the way that we get information into our class when we initialize an instance of it is by passing parameters to the initialize method, number one, and then using an instance variable to store that information. Okay? So when I call person.new, I can pass a name, and then in my initialize method, I'm going to store that piece of information in an instance variable. And that makes it available throughout my class for as long as this class instance is kept alive. All right? So let's just have a look at how that works. So I'm going to get rid of my calculator. You can keep yours. You can create another file if you want. Here, we'll create another file. We'll do that. That might make you feel better. I'll call this one. Oh, why'd you do that to me? Okay, hold on. I'm just going to do it this way. So I'm just going to create another file called person.rb and open it in code. And I'm going to say, stop, class person end. So that's my basic class definition. And I'm going to instantiate it with person equals person.new, and I'm going to pass a name. Now, in order to take advantage of that, I'm going to define an initialize method. And I'm going to allow passing that initialize method this piece of information, which is a name. Okay? Now, if I just leave it like this, there isn't anything too exciting here. And I'm not doing anything with this name yet. All right? So if I want to be able to use this name inside of here, so for example, say I want to override 2s. Now it would make sense, wouldn't it, for 2s to just return the person's name. That would make sense. But if I just try to say return name here, this isn't going to work. Can anybody tell me, just based on what I said so far, why this isn't going to work?
Because you have an initialized.
Okay. So this name that I'm referring to here is based on what's passed into initialize. But do I have access to that parameter from another method?
So as soon as the initialize press end, and that is done, that's not doing
Name's
anything.
not available. Yeah, so initialize is doing nothing right now, is one thing. It's not doing anything. But the other thing is I'm referencing here the variable that was passed into initialize. I don't have access to that from here. That's just a parameter to the method called initialize. I don't have visibility to that variable from another method in the class. It just doesn't work that way. That name variable is only available to what? Where?
Just the initialize.
Yeah. Yeah, just the initialize method. That's it. That's it. If I want it to be available, if I want that piece of information to be available elsewhere in my class, like for 2s, I have got to store it in an instance variable. And then I can reference that instance variable to get to that piece of information. So the way I do that is I just define an instance variable. I just define it. And I set it equal to that piece of information. And then what change do I have to make in my 2S? Yes, I have to use the instance variable because that variable will be available. So now when I run Ruby person, it prints Janelle. When I say puts person. Okay? So putting the the at sign in front of it, the at symbol, makes it an instance variable, makes it accessible from any method I define in this class. But it does not make it accessible outside of this class. So for example, if I tried to say puts person.name, it tells me I don't know no name. There is no method called name on person. And there isn't, is there? There is no method called name. There's no method called name. So when we have an attribute, and it's not going to work if I do this either. So you might be saying, well, put an at in front of that thing, girl. But it says, no, I don't even know what that means. That doesn't make any sense. Okay, because we can only access instance variables from inside a class. All right? So that's not the answer, because instance variables are only available inside a class. So if I want to be able to access an attribute on an instance of a class like this, person.name, then I need to define a method that gives me that information. Okay? And in object-oriented paradigm, that's called a getter. Have you heard that before? A getter. I know I say it like an American. A getter. It's called a getter.
Wait, G-E-T-T-E-R?
Yes. Yeah, a getter. And that... or you might hear it called an accessor. Right? An accessor. So I can define a method here. The way we define a getter in Ruby is we just define a method with the same name as the property without the at symbol. And we have it return what? What do you think it returns?
At name.
Yes. And if we do that, oh, did I fix it down here? I can't remember. Yeah. And if we do that, then we can call person.name. It's totally fine. So this is the way we give access to our instance variables outside of the class. We explicitly define a getter. Okay? So in this way, you can see how by defining a class, we're controlling what our user can access about this class, the instance of this class. We have control over how we can use the data that this class holds. If we just defined it in a hash, we have zero control, right? Anybody can access the elements of that hash if they have access to the hash. But by just defining a person object based on a person class, you can't necessarily access the information about that person. You can access what we tell you you can access through getter methods. Now, what if we wanted to be able to say, we want to be able to change a person's name? What if we wanted to be able to say person.name equals Vic? Do you think this is going to work? It's not going to work. So we try to run it. It says undefined method name equals for this object with name equals Janelle.
Could you define a method for like call it a change name or something?
You could, definitely. But the convention is that we can actually define another method called a setter or a setter. And the way we do that is we say name equals. See, and even it gives us a clue here. It says no method name equals. So you can define a method called name equals. And it will be passed a parameter, yes? Which will be the name that we want to set it to. And what do you think we do inside of that method?
A string.
We don't. What do you think we do? We're changing.
At name.
Yes.
Equals,
Yes.
name.
Yes. What's passed in? Yes. Now, it's totally fine with that. So let's print puts person after. Because remember, what does our puts person do?
Oh, man.
What does it do? It calls our toS method where we're returning our instance variable name. So there we go. And if I did puts person.name, we'd also see that it's been changed. Okay? So this is the way that we define setters and getters in Ruby. The syntax is different in different languages, but the idea is a common idea across all object-oriented languages. We define attributes for instance variables, and then we provide methods at our discretion to read and write the information for those attributes. Does that make sense? Now, we can add more attributes to our person. How do we do this? So let's think of an attribute we want to add. Maybe we want to add what? What's a popular attribute for age? Okay. So if we wanted to add age, now let's not add it. We could add it to our constructor, to our initialize method. We could pass it in as a parameter. We could do that. We don't have to. So let's not pass it as a parameter yet. Let's just define another attribute to our class called age. How would we do that?
Declare the
We could do this. But in Ruby you have to set it equal to something. You have to set it equal to something. We could set it to nil at first. I would. So you could put it there. But the best practice is just to define your variables, your instance variables in your initialize method, because initialize is always going to be called. So, and then we know there's this one place to look for our initialize method. So we could say at age, and we'll set it to nil at first. We don't know what the age is. It doesn't really make sense to set it to a number.
Why not?
Because what number would we set it to? That's not a valid age. I mean, we could set it to a negative number. Somebody might be 0 if they're not 1 yet.
actually raises the resolution set and then over it. And
Say that again?
you could just sort of unsign all the values or using getters and setters. You can
Yeah,
remove the negative so they
you
sign,
could.
they won't try anything.
You could. Yeah, you could. So if we did this, we could add an age attribute, but right now it's not very useful to us because there's no way for us to set it. So if I wanted to be able to set an age for a person, what would I have to do? How would I do that?
Would you do it similarly to name?
Yep.
Def age equals in
Yep.
brackets age.
Yep.
At age equals age.
Yes. And then I could do something like person.age equals 12. And then I could say puts. Now, can I do this? Is this going to work? First, let's just do this one. Okay, so now I can set a person's age. And if I do a, if I change my 2s to return something like name, colon, interpolated, name, and then age, colon, interpolated, age, I didn't set my age. Oh, because, yeah, that's right. That's right. I'm just going to put person. Okay. Okay, there we go. So that let me set the age. So what if I wanted to, can I do this? At this point, can I say person.age? Will that work? Will it? Shall we try? No. Why doesn't it work?
Oh, yeah, okay.
I don't have a geta. Don't have a geta. How do I define that? Return at age. And then that'll work, right? Okay.
In the at def age equals age,
Yeah.
age equals, could you do age dot to I to make sure it's an integer?
You could. Yeah. And that would make sense, right? So how do we decide what should go into the initialize as a parameter? Because we can see that you don't have to, right? You don't have to. So what should help us decide? What do you think should help us decide if it belongs as a parameter to our initialize? Yeah, if when I create this thing, whatever it is, if I know this information already, yeah, then it makes sense to pass it to the initialize, doesn't it? What about sometimes I know the information and sometimes I don't? Sometimes it would be convenient for me to pass in the name and age, and sometimes it's just more convenient for me to just pass the name. There's a way you can do that. So what we can do is we could say, okay, I'm going to pass the age in too, but if you don't pass it in, I'm going to set it to nil. Now, if I'm going to pass in the age, instead of explicitly, literally setting it to nil in the initialize method, what should I set it to? Age. I should set it to what gets passed in as a parameter. And this way, if you choose to pass it in, it'll get set to whatever you pass it in as. That notation that I have there, that syntax, age equals nil, in the parameter string means if I don't get this argument, use nil by default. And the reason that we do this is, say we implemented this person class at some point, and we just implemented with a name. And then later we decided, you know what, it'd actually be really handy if I could pass the age in too when I create one of these. I'm going to add age to my list of parameters, but I don't want to break all of my implementation out there that only passes one parameter. Because if I change it to now expect 2 parameters every time, all of my implementations that only pass 1 parameter are going to break. It's going to say expecting 2 arguments got 1. Okay? So now I can optionally, so my code should still work, number 1. Let's see that that's true and I haven't lied. It does. But now I can also, if I wanted to, I could say when I create this person, I'm going to pass in an age. And this first puts person. I'm just going to comment out these other things for the moment, okay? I can pass in the age when I instantiate the person, and that information is there as soon as I instantiate it. Is that clear? So yeah, go ahead, Isaac.
Just gonna ask, does Ruby support named variables? Like, my experience isn't default variables change a message you have a large quantity of.
Yes, I believe it does. So you're asking if when I instantiate it, can I say name equals Janelle, age equals 46? Yeah, let's try it and verify that that's true. I believe that's true, Isaac. Yeah. So why does that matter? Because if I had a long list of parameters where a number of them were optional, and let's say I had 2 optional parameters, 2 parameters with default. Say I said age equals nil and maybe birth year. And maybe I want to pass birth year but not age. Right? Then I could do it like, oh, let me put them in the other order. And say they were passed in like this, right? And I just wanted to pass in name and age, and I didn't want to pass in birth year. Then I could do it by explicitly saying the pieces of information I'm giving you are name and age. Oh, it didn't work. Huh?
I know if you switch C#, I know it's a colon, we put her a name variable.
So like this, you mean?
Yeah, I know that.
You could very well be right. Let's try. That's interesting, isn't it? That's not what we wanted. Okay, so let me find out about that.
Unless it's expecting a symbol as a parameter in the constructor.
Yeah, it could be. It could be. It could be. So let's leave that for the moment, okay? And I'll find out. And then I'll get back to you. So just don't worry about that for the moment. And I'll find out. And I'll clear it up. And this is going to be a syntax thing, and that's why I'm not completely clear on it, because it's different syntax in different languages. Okay, now, can you imagine if we had 10 properties of a person, and we wanted them all to be accessible via getters? That our class would get super verbose. We'd have to have a method for every attribute we wanted to expose, right? And if we wanted you to be able to set it to, then we'd have to have 2 methods for every property. And that would just really get long. Okay? So Ruby, of course, has provided a shorthand for that. So we don't have to define those setter and getter methods the way that we just done. Instead, we can use something called attrs. I say attrs. Other people say other things. Okay, I say attrs. And this is what I mean when I say attr. A-T-T-R. So we can say attr assessor. All right? And then we use symbols when we define our getters and setters this way. So we can say attr assessor, name, age. Okay? And then we can get rid of all of this. All of our getters and setters. Because that does this for us. Attr assessor is shorthand for get and set methods for every attribute we list. Okay, so let's just make sure it still works. It does. Now, what if we only want read access, meaning we only want to provide a getter? We don't want you to be able to change your age, for example. Or maybe you want to change your age. Maybe we don't want you to change your birth year if we had a birth year. So if we added in a birth year, and we set it equal to nil. We're just going to hard code it for the moment. We set it equal to nil to start. And we wanted you to be able to, let's say we have a method to set the birth year initially. Now we'd pass it in, wouldn't we? That wouldn't make sense otherwise. Let's do this. Okay, let's say that we pass in those three things. We could probably figure out age, couldn't we, from birth year? Yeah.
Sorry, I just thought, I'm guessing it's the same root, but it might be worth pointing out that when you have default values passing these parameters, you do have to place those parameters after
You
your
have to need
non-optionals.
current
Say
year.
again?
Like if you're going to have
Minus
name and then age equals 0 or nil, you would have to define anything that's not optional before your optional parameters.
Yes.
I'm not sure if it's the same in Ruby. But I'm
It
thinking
probably is. So I'll do research on that whole topic, and I'll
Yeah,
come back
I
with it.
Just thought just before somebody starts trying to throw in defaults and then
Put requireds after. Yeah. So what Isaac is saying is, if we are not going to provide a default value, meaning it's an optional parameter, if it's a required parameter where we expect that they're going to pass it in, those need to be listed first. So I'm just changing my implementation up a little bit, and I'm just going to pass in a birth year, and I'm going to get the age from the birth year. And I'm going to hard code it for now instead of using time.
Current year.
So I'm going to say age equals 2019 minus birth year. And I know this isn't accurate, okay? We're going to leave it. We're going to leave it be. All right? Now, because the point I'm trying to make is that we may not want to allow somebody to change their birth year once they told us what their birth year is. I mean, your birth year is your birth year, right? No change in your birth year. That's cheating. So, maybe we do want people, though, to, we want people to be able to change their age, though. Right? So we set the initial age based on a birth year, but then maybe a person has a birthday, and we don't recalculate their age. You have to update your age, but we're not going to let you update the birth year, the initial birth year. So if we didn't want you to be able to change birth year's value, but we wanted you to be able to see it, then we could use an adder reader. An adder reader says you can read it, but you can't write it. In other words, it provides a get method, a getter, but not a setter. There is an adder accessor for writing only, and it's adder writer. Pretty sure it's writer.
yeah.
Yeah. Okay. So there's adder reader, adder writer, and adder assessor, and adder assessor gives you both. So now let's just make sure my program still runs. Age 1973. That's not right. Why did it do that? Birth year 2I. 19. Oh, because I'm passing in 46. That's when I was born, by the way, y'all. It's the best. Yeah. It's the best year. Okay. Now it's going to give me what I expect. There we go. So I pass in the birth year and the name. And why when I say puts does it give me age? When I say puts person, why is it showing me that?
That's what you define in the string.
Yeah, that's right, because that's what I defined here. Right? Remember, so puts calls to S. Now, based on my my outer declarations here, will I be able to do puts person dot name? Will I be able to do that?
Yeah.
Yep. Will I be able to do puts person dot age?
Yes.
Yeah. Will I be able to do puts person dot birth year? Yeah. Yeah. Will I be able to do person.name
Page.
equals something else? Yep. Can I do person.age equals 47? Can I do that? Can I do person.birthyear equals 1980? I can't. Why?
Because you only give a read-write flag, like actually read-write for birth year.
That's right. So when I try to do that and I run my program, like I expect, it tells me I can't find a method birth year equals. Why does it tell me that message? No method birth year equals. Why does it tell me that?
Because you haven't.
Because I've got no setter for birth year. I haven't defined birth year equals method explicitly, and I haven't defined birth year as an adder assessor. Okay? So if it's not crystal clear, it's okay. These are the things that I want you to take away. That instance variables are declared with an @ symbol. And they are available everywhere inside of a class, but not outside of the class. We make instance variable values available outside of the class with a getter method or using one of these adder declarations. Adder accessor or adder reader if we want it to be readable. Adder accessor or adder writer if we want it to be changeable, settable, writable. Okay? The appropriate place to initialize instance variables is in the initialize method. Instance variables that we want to be initialized when we create an instance of a class with new, we pass as parameters to the initialize method. Okay? Those are the things that I want you to take away right now. Are there any questions about any of this? Yeah.
Can you override a default, if you're using like auto setters like that, can you override one by manually defining it later on?
I think it would do, Isaac, just understanding that's based on an assumption I'm making,
Yeah.
that adder assessor being at the top would be defined first. And then if I defined a setter method, for example, or a getter method inside, that would override what's given there. We can check it.
I thought it'd be good for like validation without having to then manually, like you'd have to put it in reader and then manually define your.
Yeah, that's right. So so you're saying you could define everything as an adder assessor.
Yeah, and then just override the setter.
Yeah, or define everything as a reader
Well,
and then
just-
provide a setter.
If you would just to say having to define it as a reader and then manually write the setter, if you would just define it as an accessor.
But if you define it, how would you override it though to make it not available?
Yeah, so if you have an access like that and then you had age equals,
Yeah.
just to say like you could even just say puts invalid.
Okay. Yeah. Not supported or something. Yeah.
Yeah. It's
Yeah.
just data validation.
Yeah. Yeah. And then let's see if it does what we think. Yeah. All right. So I think let's have a look at what else is in here. See if there's something else. So we talked about this. So we can add any methods we want to a class. So we just looked at, with this person class, all we've defined, we overrode 2s, and we provided getters and setters. But otherwise we haven't provided any additional methods. But when we looked at the calculator class, we saw we can add whatever methods we want. Whatever methods make sense for this class. And the methods that make sense are what are the things I want instances of this class to do. Or what should I be able to do to them or with them? Those are the methods we define. So with the calculator, we should be able to add 2 numbers with a calculator. We should be able to subtract 2 numbers with a calculator. So we had methods that do those things. Depending on what we're using this person class for, maybe we would have methods to have the person say hello, or to add a person to an activity or something, or add an activity to a list of activities the person does. Depends on what we're using it for. But we can add any methods we want to a class, and the methods that we add should be related to what we can do with an object of this type, or what we want to do with an object of this type. And we're going to look some more at this over the next, from now on, we'll start looking at examples, I think, most mornings, not every morning, but at least a couple mornings a week. We'll take an example problem and we'll look at how would we define classes to represent and solve this problem. And we'll just practice that every morning, because it's one of the hardest things about programming, I think, is looking at something you want to create. How do I start? What are the things I need to represent in this application? And what do they do with each other? How do I use them? So we'll start to practice that and you'll get used to it. Okay, so composition. We can include classes as objects within other classes. Okay, so for example, let's say that we wanted to associate an address with a person. Well, an address isn't just one little piece of information, is it? In an address, we have the street, number, and name. We have the city. We have the state. We have zip code, country. All of these different pieces of information in an address. Anytime there's more than sort of like one simple piece of information, I want to represent it as a class in Ruby. I want to represent it as an object. So we could, for example, define an address class with whatever is important for us for this application. Maybe we don't need to know country. Maybe everything for this application happens in Australia, so we don't have to keep track of the country. Maybe we just need the street, the city, and the postcode, and that's fine. So if we just take this code here, and let's make sure it makes sense to us. So above where we define the person class, we'll define this address class. So let's look at it. Our initialize method, we pass a street, city, and postcode. And then what do we do inside the initialize method? What do we do in there? Someone, anyone? What does our initialize method do with those parameters it gets passed? Yeah, we're just storing them in instance variables. And why? Why?
So we can access them outside that method.
Yes. So we have access to them all throughout this address class, right? So then we can define a method called full, which gives us back the full address in a formatted string. For example, we might want to do other things with it. So now let's say we want to add an address to our person object. We could pass in an address to our initialize method, and then we could define an instance variable called address that we set equal to that parameter, and we could make that address accessible. And then how am I going to pass this address when I instantiate a person? What can I do? Does anybody have an idea?
So where you normally write like the one word.
Yes.
That you put in what the initializer of address is called.
Yeah. So let's do it in 2 separate lines, Carly. So before we call initialize on person, let's set up an address object. Let's do it in 2 separate steps, and it might be more clear for people. So how would we instantiate an address object?
Go like address equals then a capital address, dot new,
Yep.
and then in brackets, you put, that Maple Street and the street name,
Mm-hmm.
and then, another one for city, and another one.
Like this. And then what would I pass into person?
So in, after Janelle, we would just put in the, variable address.
I'm just looking for how I did it here. So it actually comes.
At the end, at the end.
Yeah, it comes after birth year. So we have to look at what does our initialize method expect as far as the order of parameters. So it expects name, birth year, address. So when I call person.new, I'm going to pass name, birth year, address. And then how are we going to check to see that address was set? Well, we could put it here. And then we could make use of this full method on address. How would we use that? How could I use that? What would I put in here?
So that
Add address.
Yes. And I might say what? Yeah. What is that going to do? Add address.full.
Get a return value from that method.
It's going to call the full method on my instance of address. And that instance of address is created here when I call address.new. And I'm passing that instance to my initialize method on person. And in this, say this is called class composition. I'm using a class from within a class. My class person is composed of some string and number attributes and an address object. Right? So let's see. There we go. So you can see that my person object, my person class, doesn't have to worry about what makes up an address. It just thinks of it as an address. It's just an address. It doesn't care that it's made up of a street and a city and a postcode. And if I wanted to go change what makes up an address, I could do that. And it doesn't affect person. Person doesn't care what an address is made of. It just knows it has an address. Okay? So in this way we separate those responsibilities. Address is responsible for its information and how its information is displayed and what information it keeps track of and what of that information is accessible. And person is worried about what makes up a person without worrying about the details of what makes up an address. Okay? Now I put all of this in a single file, but you wouldn't do that. You would create separate files, okay? And we'll talk about that maybe after lunch. I think it's probably time for a break. You guys feeling a little bit brain tired? Just a little bit? All right. So afterwards, I think after lunch, maybe we'll have a talk about modularizing a little bit. But let's take a quick look at the afternoon challenge. Okay, so first is to try to work out what would be an attribute, what would be a method, just by the way things are named. And then you build a cat class where a cat has a name and a speak method that says meow. And add the cat's name to the speak method. So Pixie says meow.
Then it talks to the dog halfway through.
Yeah. Yeah, and then your cat, your cat turns into a dog. Ah. Okay, so you can start with a dog if you want. Or you can decide that your dog is a cat here too, and I won't mind. Yeah. Whichever makes you happy. Okay, so you can start to look at this after lunch if you want to, but let's meet back at 1:15, okay? And at 1:15, I'll give you a little bit of time to maybe work on the first part of this challenge, maybe like the warm-up in number 1, and then we'll talk about separating classes into files a bit. I also want to give you that other challenge that I made up today to try without the internet. So we'll do that this afternoon. And yeah, and then we'll have a look at these challenges together a little bit later in the afternoon, like maybe around 3, something like that. Okay, make sure everybody's on board with what we covered today. All right, thanks guys.